Okay, this video we're going to be talking about using the Wronskian value to determine if if functions are independent or dependent. So the Wronskian itself, if we're talking about three distinct functions, let's say f of x, g of x, and h of x, can be set up as a 3 by 3 matrix that we'll find the determinant of. So row 1 are the functions themselves. For the sake of space, I'm just going to use our letters f, g, and h. Then row 2 is their first derivative. So that's going to give us f prime, and then g prime, and then h prime. And then row 3 is the second derivative. So f double prime, and g double prime, and h double prime. So what we're looking for here is the determinant of the matrix W. So if W is equal to 0, then the functions are linearly dependent. If the function is, or the determinant, sorry, is not equal to 0, then the functions are linearly independent. So we're looking for this value that comes out of this 3 by 3 determinant. This next slide is just a review of 3 by 3 determinants in case it's been a while. You can use any method to solve them. If you have technology that will work, great. Some calculators won't take a variable input, and some of our functions, of course, are going to have either trig functions in them or algebraic functions. And some students may have learned this using minors and cofactors in the past, and if that's your approach, that's great. There's another technique that we can use on 3 by 3 that a lot of you will be familiar with. So if you don't remember the details, this is where we're coming in. So we're going to repeat the first two columns on the outside. So I'm just going to rewrite whatever my values for f prime, and f double prime are. And then the next column would be g, g prime, and g double prime. So whatever those values are. Then any diagonal that goes, or value that goes down to the right. Okay, so these functions are going to be what we call the principal diagonal, and we're going to multiply all three of those as we're going across. So we're going to get that out of the way. So when we calculate this, we're going to bring in, let's get that out of the way. All right. So we're going to multiply for the principal diagonal, f times g prime times h double prime, and then we're just going to add up all of our principals. So the next one would be g times h prime times f double prime. And then we're going to add to that h times f prime times g double prime. So what we've done is just moved across. So there's our first diagonal, and then the second, and then the third. Okay, that's a principal diagonal. Then what can be referred to as your secondary diagonal are the ones that go up to the right. And it doesn't matter if you start at the front end, or some people start at the back and then move their way in. Doesn't make any difference. But we're going to subtract our secondary diagonals. So our secondaries, let's put a little s up here, are going to be h times g prime times f double prime, plus the next one will be f times h prime times g double prime. And our third one will be g times f prime times h double prime. Okay. Then when we take those, all three of our principal values and add those together, all three of our secondaries and add those together, the value that we get in the end is the value for our 3 by 3 determinant. So we're looking to see, is that equal to 0 or not? So our homework example, we're going to use the Wronskian to determine if these functions are linearly dependent. In other words, does W equal 0, or are they independent, so W is not equal to 0? The three functions we're going to start off with for now are 13 and 4x and 6x squared. This is definitely not the only technique of a way to tell if things are independent or dependent, but we'll use this Wronskian in other areas as well. So we're going to go ahead and go through this technique for now. So if we write up our 3x3 determinant, normally we read matrices by row. I'm going to do these by, we'll put our first row in, so 13, and then 4x, and then 6x squared. There's no comma or anything there. But then when I do my calculations, I'm actually going to do them by column because we're looking for the derivative of each piece. So the derivative of a constant is 0. So that first column is 0 and 0. Our second column, the first derivative is 4, and then the derivative of 4 is 0. In our third column, the first derivative is 12x, second derivative is 12. Now, any technique, some of you might notice that you have a corner triangle of zeros. So the value of your determinant is the principal diagonal. That'll work whether it's a top corner of zeros or bottom, or you can rewrite them, whatever technique you want to do. We just want to figure this out. So in our case, this is going to end up being 13 times 4 times 12. Every other diagonal we could create would have a 0 in it at this point. And when we multiply those together, 13 times 4 times 12, we're going to get 624, which is not 0. So if the function is not 0, it's linearly independent. Okay, I hope that helps.